It has been said that you cannot see the forest for the trees. And here we are amongst the trees. We just took a shot to get our bearings on the railroad that runs at the base of the escarpment here. And we're just going to go looking for some dendritic ridges, Michael Steinbacher style, and walk across and see if we can find any of these things. So here right away we are on, I believe, the second day of spring, the 21st of March. We saw Google showing us it was the vernal equinox yesterday, which is a nice way of saying it's the first day of spring, meaning the sun is or was directly over the equator. And the sun plays a role, according to suspicious observers, in that it affects us and events such as weather and quakes. So we are just climbing up this hill slowly, not too far from home, and looking at lots of lumps and bumps here, wondering where they came from. So what we want to do, this is the Brantford Rail Trail here. A little lump or bump there, it cuts straight across. Used to be a railroad, I assume, given the name, and the gentle incline, I think, running up to the right and down to the left, just used as a trail. And just noticing what I might presume to be limestone cut into bricks, used as a retaining wall here, so the railroad, now a trail, can come through. So what I'm trying to do here is work with the term I came up with last night called synthetic history. Synthetic history I will define as trying to put together 4 fields of investigation: geological, archaeological, technological, and genetic. So that's looking at the evidence that's left by past histories, the evidence that is left by geology, our genetics, which we can look at objectively, and also the technical aspects of our history and how that has influenced us. And the reason, as has been defined elsewhere, if we know where we came from, who we are, and why we are here, it can help answer the question of where we ought to go next. The typical point of view, as I turn around here, is that all of this was formed about 6,000 to 10,000 years ago by a creator God, and we are here as a result. This is the view put forward by the creationists. The evolutionists and Darwinists would say that this world in which I stand was formed about 4.5 billion years ago, and life formed about 3.7 or so billion years ago. And then we are here as a result. And Tellinger, Sitchin, Pye, Bolter, and others imply or say quite clearly is that we are here because we are a hybrid, a mix of genetics of hominid and non-Earth species. So I'm leaning, or find the evidence points to the last one, that is the fact that we are hybrids, and perhaps the fact that I'm interested in this could be due in part to the fact that my genetics come from elsewhere, and so I find this quite fascinating to think about where we are from, some whose genetics might trace more directly to this earth, such as, for instance, I speculate the Rh positive people, which is the majority of the population, might find that hard to digest. So we are here right now just looking at the geological aspect of our history and wondering if these lumps and bumps and if this huge slope going up to my right could have been caused by erosion. I would say point blank that it can't. There's way too much turf, way too much fallout, extending up to my right a few hundred feet and extending down to my left a few hundred feet. You can see I may be about halfway up. There's just too much fallout, too much mass of earth coming down and below me and to the left to have fallen from the non-existent height up above me. And you can see it perhaps just up there with the apartment on top. You have almost a straight drop of about just under 100 feet, perhaps 70 or 80 feet. And then you have dirt and 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 dirt. So my gut tells me this isn't erosion. It isn't. I've worked with dirt. Dirt has to come from somewhere. It didn't come from up there. There's nothing there for it to come from. It came from somewhere else. And that somewhere else, I think, is defined by the hybrid version, the version put out by Steinbachers and Thornhill and Talbot and others, which says our universe is electric. Folks, wake up. It's electric. This is electrically formed, this snowdrift escarpment here. It's not geological. There's no place for the dirt to come from. I've moved lots and lots of dirt. It has to come from somewhere. There's nothing up there for it to come from. There's no mountain. It's just a straight drop, and this isn't windblown. This is a massive amount of dirt. It's not a geological formation. Oh yes, Dendritics, we're going to walk along the rail trail and let the camera do the work. So now we just come down the hill from about halfway up, and we're just waiting for some people to clear out before we start recording the trail, just to let the viewer look for themselves. But we can see it looks kind of boring here. There's not much. There's just a hill roughly going up, but again, it doesn't really look eroded. It looks kind of lumpy and bumpy, and not just like a straight erosion process carrying this material down the hill. So if we keep the camera pointed to the right, we'll just walk along here and comment if we think we need to. Just a huge variety in the lumpiness of this scree or whatever it is. There's no real consistency. And we just walked a few paces before turning the camera back on again. Just have a little Samsung DV300F. Does a nice job. I'm using KDN Live on some VMware on a Windows platform. KDN Live is open source. It stitches these videos together quite nicely. Again, very boring looking terrain. It could be that some of this lumpiness is caused by an excavator just tossing the extra uphill. I don't really know. I'm just recording as I go, and I haven't walked along this part of the trail just yet. And down and to the left, a little less of a slope. And again, nothing terribly interesting to look at, except for the fact that these are all deciduous trees. As far as I can tell, there's no pine, there's no conifers, meaning the soil is not that acidic and perhaps sedimentary based, and thus favoring the deciduous trees here right now. Now we see a section of the trail which is cut through a little part that was a wee bit higher than the rest, and we're not seeing any rock outcropping, so we're assuming that it is sediment. We're looking at dirt, not sand, on the top here, just with a light covering of leaves. So we haven't really taken the step. And there's one of those larger rocks just coming from out of nowhere, just sticking there on its side like it got thrown or washed down, again with this dimpling process, which is said to be caused by acidic water, and I'm thinking that could be in part due to electrics. I don't know at this point. Those are the only two forces I have to work with right now in my working lexicon of geology. I code or try to code part-time to earn enough to put bread on the table, but I find this relaxing to come out into nature. I've always liked being out here. We are fortunate to have a cut like this through the city. So here's the closest thing to anything that could be termed dendritic. It looks like it could be, I would say probably is due to erosion. Don't know where that's coming from, but we do have a slight depression here. Looks like erosion. Can't be sure. That's the closest outstanding dendritic part pattern. This would be the bottom of the rill, and that's about it so far. And just following that dip valley behind there, following over this little hill caused by a cut, and then we see what looks like could be more the same, perhaps erosion, I'm just not sure, but we do see some kind of a depression there. Again, we don't know what caused it, so we can't assume one way or the other, except to note that it's there along with this ridge, which looks at least in part man-made, as the real cut is just coming through to my right here. So we'll just carry on along the top of this ridge. More interesting than walking on a man-made trail, that's fine. Moss-covered rocks. Again, lots of randomly placed, square cut, eroded, dimpled rock. Just collect some raw data here, so there's something to work with back at the desk. Dimpled rock. I really don't like this because I really don't know what caused it. Not just on the one side, but on two sides for sure. Maybe three. Kind of like four. Yeah, right. So, help me, as my former employer used to say. What does all this mean? I really don't know. So far, I'm recording it. Get a bot to do this. Could not quite fit through here. I think you have to be bipedal. Picture C3 view doing that. Or two would have a tough time. Again, more random rocks. log, the random rock. No problem in finding something to hit your head against when you can't figure it out. That's very nice. Sun coming through. And again, as we look at this, thinking about various events in our history, how we got here, why we are here, keep living on this little planet we have. Just a minor detour to look at some fungi growing on the tree. I think if it's edible. Smart fungi. Dumb people. And as you can tell, I get bored with walking on a straight path, so we'll walk through something a little more challenging, which is the whole point. Where do these rocks come from? There's this water, erosion, gravity, combination of the above, naturally induced catastrophe, flood, deluge, I do not know. People smarter than I can answer those questions. I'm just asking them. Yes, lots of acidic water on that one. Giant wilder. Oh, look, a straight cut rock. No acidics. Oh, wait a minute. Well, dimpling. Challenge for a guy who's used to looking at code. Nothing here to tell me where this is coming from. I think that is in part the challenge, or part of the answer, is to get people who are a little naive about this subject area over a piece of steel, because those who are naive may ask different questions, find a different set of answers than those who have been trained to look at it for one way for so long.